Welcome to homework.
In this question, uh, it gives the setting that A is some set that is not empty, and we have R as equivalent relation on A. We are asked to show that there exists a function, call it f, with A as a domain, such that for any ordered pair xy in the relation R, xy will be in relation R, even only if the value of the function fx equals to fy. This may look a bit confusing at first, but essentially x and y are elements in A, and we want the function be such that this these two things happen whenever the other happen. So if x y is in the relation, then the function map them to the same thing, or if the function map them to the same thing, it must be in the relation. Okay, so I will show one of the way to build this. There are many ways to do this. First, since A is non-empty and has equivalent relation R, A will has a partition, call it A1 to AN, where AI is equivalent class of R. So each AI will be equivalent class of R. We can do this. You probably have seen some example or other question that use this property. So any equivalent relation can create a partition on its set, and the partition is such that the union of everything made up the whole, but any pair of the parts, is equal, has intersection as empty set. So they have nothing in common, but they all made up A. All right. And when we can do this, then is very simple to build a function that we desire. So I will build f as a function from A, the set, to the set of its partition. So inside this set, we contain this A1 to AN. Each of them is a subset of A. So each of them is a set with some element, right? And all of them made up A. We define the function as sending x, an element of A, to some set inside here, such that x is an element of that set. It exists because everything made up A, right? So x will appear in some AIs, but x will appear in only in exactly one AI. It cannot appear in both of them, like any two of them. If x appear in both of them, then the intersection will not be empty. So we are safe to say this, right? Essentially, we send x to its equivalent class according to the relation R that we have at the beginning. That's essentially it. The partition is, as I said, the equivalent class after all. So when we do it like this, when fx equals to fy, it means they are the same, like they are some set, right? Call it ai0. That means that x is in there and y is also in there. And since this is equivalent class according to relation R, then the pair xy must be in there. xy or yx, both of them, yeah, will be in there because I is equivalent relation. And this go both way. If we start from here, we're gonna have this anyway. So this is if and only if. And so we have shown that we can build one function with this property. And that is how you do it. Thank you.